Hello students, how are you? How are all of you? Okay, today I am going to teach you about torsion. So what is torsion? Torsion is the effect that when we apply one torque to a shaft, then the shaft rotates. For example, this is one shaft, correct? So if we apply one torque to this shaft, now what is torque? Torque is a type of moment. What is moment? Moment means which is having a rotating effect. See, when we give a force to a body like this, when we give a force to a body like this or like this, what happens? The body displaces, correct? The body has some displacement, linear displacement, okay? And more phenomena occurs like bending, shear, the other things happen. But when we apply one moment or a torque, the body rotates, okay? So what is torsion? That when we apply one torque to a shaft, then it rotates and it also develops shear stress. So these phenomena we will discuss in today's topic, that is torsion. So let us start with the board work. Yeah, okay. Now as you can see over here, as you can see over here, see, T by IP is equal to tau by R is equal to G theta by L. This is the basic torsion formula. What is it? T is the torque applied to the shaft. IP is the polar moment of inertia. Tau is the shear stress developed due to this torque applied. R is the radius of the shaft. G is the modulus of rigidity or shear modulus. L is the length of the shaft. And theta is the angle of twist. Angle of twist. As I have explained you that when you apply a torque, the shaft will twist like this way, twist. So this is the angle of twist. Remember, the theta is measured in radian. Okay. Now what is IP? IP is the polar moment of inertia. It has come from the perpendicular axis theorem that polar moment of inertia is the summation of Ixx and Iyy. So here we are taking a solid circular shaft. So IP, polar moment of inertia, is pi by 32 d raised to 4. What is d? D is the diameter of the shaft. So this is the basic torsion formula. This is the IP. Now we are coming to the next concept as torsional rigidity. What is torsional rigidity? Torsional rigidity is denoted as GIP. So if we take these and these, 1, 2, 3, these are the three parts. If we take part number 1 with part number 3, so what will happen? We can write it like this way, cross multiply. So GIP is equal to T L by theta or T divided by theta by L. We can write it like this way. Okay. So what is torsional rigidity? Torsional rigidity is GIP, product of G and polar moment of inertia, shear modulus and polar moment of inertia. But how we define it? We define it that torsional rigidity is the torque which is required to provide an angle of a unit angle of twist for a unit length of the shaft. I repeat, you can write it down. What is torsional rigidity? Torsional rigidity is the torque required to produce unit angular twist for a unit length of a shaft. So this is torsional rigidity. Next is the torsional stiffness. Torsional stiffness K is denoted as K. This is equal to T by theta. K is equal to T by theta. Now the main purpose of the shaft is power transmission. So through shaft we are transmitting power. So what is the power transmitted by a shaft? So P is equal to 2 pi n T divided by 60. So you write down the meaning of the notation. 2 pi, you know what is n? N is the number of revolutions per minute. N is in RPM, number of revolutions per minute. That's why we are dividing it by 60. If it is given as RPS per second, then this component will not come. R is in RPM, hence it is divided by 60. What is T? T is the torque applied, as I have told you earlier. Now how we can find an expression of shear stress, tau, from here? So now we are taking 1 and 2. 1 and 2 if we take, can you tell me what will be the expression for tau? So tau will be T R by I P, right? Taking 1 and 2, T R by I P. T, what is R? R is equal to radius, so that is diameter by 2, D by 2. What is IP? Pi D to the power 4 by 32. So if you cancel it, you will see that it will come 16 by pi D cube and T. So this is the expression for shear stress, 16 T by pi D cube. Now I am coming to the hollow sphere part. So in case it is a hollow sphere, please remember this IP value is pi by 32 DO raised to 4 minus DI raised to 4. What is DO? DO is the outer diameter of the shaft. DI is the inner diameter of the shaft. Here what the most students make mistake, they write the formula as pi by 32 DO minus DI whole raised to 4. That is wrong. What? DO minus DI whole raised to 4. That is wrong. It will be what? Pi by 32 DO raised to 4 minus DI raised to 4. Okay. Now, the final thing is FOS, factor of safety. Factor of safety is defined as the ratio between ultimate shear stress divided by the safe shear stress. So I hope you have understood this entire middle column. Now the question is why I have told you about all these things. See, first of all, this is the basic formula. You have to memorize it. You have to know it. Then what is IP? And this one, torsional rigidity, torsional stiffness, power transmission, shear stress expression, and this factor of safety, all these come as a theory question in the gate. So when you will solve the theory part of the torsion, you will see that all these things I have already covered over here. And so now we will be going to start with the numerical question. As I have told you that I will take question number 1. Question number 1. Okay. So I think the board is visible to you. Okay. So what is question number 1? This is also gate question from civil and mechanical. 4 questions I have taken it. So a shaft of diameter 2 centimeter. A shaft of diameter 2 centimeter. Diameter notation is D. So I have written D as 2 centimeter. Okay. Is having allowable shear stress, that is tau, as 10 kilonewton per centimeter square. It is given in the question. We have to find what is the maximum torque developed in the shaft. Is the question clear? Shaft diameter is given, allowable shear stress is given. We have to find the maximum torque of the shaft. So for this question, how we will proceed? You please try it, pause the video, try it and tell me that how we were going to do it. And please put it in your comment box also. Okay. So this is D. Now we know what will be IP. IP will be pi by 32 into 2 raised to 4. We can find this value IP. Okay. This tau is given T. So we will take this value, this first and second formula, correct? So here R is equal to D by 2, that is 2 by 2, 1 centimeter. So T by IP is equal to, tau value is 10 by R value is 1. R value is 1. So T is equal to 10 into IP. Please see whether you have understood it. Please see whether you have understood it. So the answer is given as 5 pi. This is answer. This is the option. Option was given as 2 pi, 3 pi, 4 pi and 5 pi. So the answer will be 5 pi. It is as simple as that. Okay. Here you see 2 to the power 4 means what? 2 2s are 4, 4 2s are 8, 8 2s are 16. So this is coming as pi by 2. So 10 IP is 10 into pi by 2, that is 5 pi. Very simple. Next question. Question number 2. A shaft of diameter 25 mm is having allowable shear stress 42 MPa. Shear modulus is given as 0.84 into 10 to the power 5 MPa. Angle of twist produced as 0.01 radian. You see that I have written C over here. That is radian. Okay. So the length of the shaft is how much? Length of the shaft is how much? Okay. Now see how we do it. Now for this formula we have to take which one? This and this. Second and third. Second and third. So tau by r is equal to g theta by L. This we have to take, right? So what is tau? Tau is given as 42. What is r? Radius is equal to diameter by 2. So 25 by 2. G is this, correct? This is given. Theta is 0.01 and this is L. So we have to find the value of L. Is it clear? Is it clear? Please put your answer in the comment box. How much you are getting? $250 millimeter. Is it okay? Okay, so now we will solve this part of the question. Yeah. So question number 3. Now let us take one. Yeah. A hollow shaft problem. A hollow shaft of outer diameter is 100 millimeter. Thickness is 25 millimeter. It is having allowable shear stress 125 MPa. We have to find the maximum torque developed. We have to find the maximum torque developed. So first what we have to do? We have to find the IP. So IP is equal to, as I have mentioned over here, this formula, right? So IP is equal to pi by 32. Outer diameter 100 to the power 4 minus inner diameter will be how much? See, 25 is the thickness. This is the hollow shaft. Outer diameter is this. 25 is the thickness, means this is 25, this is 25. So inner it will be 50 less. So inner will be 50. 100 minus 50, 50. Is it okay? Is it okay? So IP is this much. Now shear stress is given. We will go for 1 versus 2. This one. So T by IP is equal to tau by R. Now R, you remember, always it is the outer diameter by 2. This is the another point of mistake, that what you do 100 minus 50 by 2 or 50 by 2. No. It is the outer diameter. Half of the outer diameter is the radius. So T will be equal to tau. Tau is 125 into this is IP and this is R. R value is equal to 50. Already we have got now 50. Sorry. So you calculate the value of IP and the final answer is coming as 23 into 10 raised to 6 Newton millimeter, or 23 kilonewton meter. This is the answer given. Okay. See whether you have understood it. Last problem for today's class. A shaft of diameter d and number is having number of revolution n and generating 90 kilonewton power. Okay. A shaft is there of diameter d and it is going through n, capital N, number of revolutions, and it is generating 90 kilonewton power. Now if the diameter is doubled and number of revolution is halved, what will be the power generated? So this is one problem regarding the power generated by a shaft, as I have told you. Okay, so how we will go for it? What is the formula? P is equal to 2 pi nt by 60. Okay, see this formula, P is equal to this. See, P is equal to 2 pi nt by 60. Now 2 pi 60, these are all constant. What is varying over here? N and T. Now T, torque, is also related to the this radius, right? So we can take this part as common, correct? And what is the relationship of T? What is the relationship of T? See, yes, so see, T is equal to tau IP by R. From here, tau IP by R. Now IP is equal to pi by 32 d raised to 4 and R is equal to d by 2. So from here we are getting that tau pi d cube by 60. Now all these are constant, only d is varying, okay, diameter. So we can tell that torque is directly proportional to the diameter cube, correct? So from here we can, what we can say over here now, in case of P, we can tell P is proportional to N into T, because see 2 pi 60, these are common. Now what is T? T is proportional to D cube. So that means this is proportional to N into D cube, correct? This is constant, this is constant. Now this is first step. Now what happens? The diameter is doubled. So now new diameter is 2d and n is half. So new number of revolution is n by 2. So what will be the power? Power will be, this will be, n dash will be n by 2 and d dash will be 2d whole cube. That means what? N into d cube, this is 8 and this is 2, 4. So what happened? So what will be the answer? Now the new power is 4 times n d cube. That means proportional to 4. N d cube means what? P, na? P. So what is P? What is P? P is given as 90 kilonewton. So the new power will be 4 into 90, that is 360. Sorry, very this is silly mistake. This is not kilonewton, this is kilowatt. The unit of power is watt or kilowatt. So the 360 kilowatt. Is it okay? Okay. Okay. Now you tell me that how you liked my today's session on torsion, and please let me know in the comment box. I also take online tuitions for the GATE and the semester studies, as I have already told, and if there is any doubt from the online lectures I am putting it on, please put it in the comment box. And if you like my lecture, or if you like my videos, so please press the like button, and also do subscribe my channel, because your motivation only keeps me going. I will upload more videos, and please let me know which topic I should take next. You can mail me at prof.meghadatta@gmail.com. I will definitely give you answer within 24 hours. So you can have a demo lecture, or whatever, only doubt session, whatever way you want me to cater you, I am always available. So that's all for today. Bye bye. I will come with another topic in the next class. Bye.